Good evening, everybody. Welcome to Science Access. Today, we'll be diving on question and answer on limits. Please, for better understanding, I want you to watch the introductory part of this course for better clarification. Without wasting time, question 1, limit. What is the limit of this problem as h approaches 0? First, look at the question. Pi bracket open arrow plus h bracket close raised to power 2 minus pi arrow square all over h. Now, seeing this, limit h as h approaches 0 equals to pi. Mind that before you proceed with questions like this, you open the bracket. As you open the bracket, you have this minus pi arrow square all over h equal to. Now, that one bracket open pi. You multiply this with this to get this. Pi arrow times arrow give you arrow square. The arrow times h will give you arrow h. Now multiply the h plus arrow, give you the arrow h by the h plus h, give you the a square. Bracket open minus pi arrow is to power 2 all over h. Now we see pi bracket open arrow square plus arrow h plus h square bracket close minus pi arrow square. Now we have limit as h approaches 0. Pi, you see there is difference between this and this. What we just did that we added this arrow h plus this arrow h, making it 2 arrow h. That is the difference between this and this. With this one here minus pi arrow square all over h. Okay, now equal to bracket open. We use this pi to multiply through the bracket. We want to expatiate this bracket. Now, by doing this, we must use pi times arrow square. We have pi arrow square. Pi times 2 arrow h. We have 2 pi arrow h. We use the pi again to multiply the h square. We have pi h square. Bracket close. We repeat this one here minus pi arrow square all over h. Okay, now limit as h approaches 0. Bracket open. Now we collect like terms with minus because there's a minus sign here. Remember, there's a minus sign here. So this one tends to cancel this one. Pi arrow square minus pi arrow square will just give us nothing, which is 1. 1 multiply the bracket just to give you the bracket. Now we bring this one here. 2 pi arrow h plus 2 pi h square all over h. We break this face to this place. That's it. And now to expatiate this is synonymous to this. You can put it this way, you can put it this way. For better on, we just want to expatiate this. Now we have 2 pi arrow h all over h plus pi h square all over h. It's still the same thing. Now we tend to cancel, h tends to cancel out each other. H cancel out this h, leaving behind 2 pi arrow, while this h cancel this h square, leaving behind pi h. Now we now repeat these thing values in this place. Limit as h approaches 0 equals 2 pi arrow plus pi h. Remember, it is h approaching 0. Now, wherever we see h, we substitute it by 0, by replacing it by 0. Now, wherever I see h in this equation, we replace it with 0. Equal to 2 pi arrow plus pi. Remember, there's a h here. Wherever you see h in this equation, remember I told you we put 0 in place of it. Now, 2 pi arrow plus pi. Anything times 0, remember our number mass. Anything times 0 will give us 0. So this one tends to cancel out, leaving us with 2 pi arrow. So this answer is 2 pi arrow is the answer to all these solvents. Now question 2. Evaluate limit as s leads to infinity. Question like this, there are rules in which we solve this. Limit lead to infinity. Now, according to the rule of limits lead to infinity, We divide this question with the highest number of x at the denominator. Now, the highest number of x, power of x at the denominator is x raised to the power 1. Now, we divide through by x. Limit as x leads to infinity, 8x divided by x minus 3 divided by x all over this 7x divided by x plus 5 divided by x. We cancel. This x cancel out this x cancel out this x. So there's no x here to cancel out. We leave it like that. Now we write this again. 8 minus 3 divided by x all over 7 plus 5 divided by x. Now we substitute wherever we see x, we replace it by this infinity sign. There's 8 minus 3 all over infinity plus 7 plus 5 all over infinity. Now, at this point, anywhere we see infinity, we replace it by 0. Anywhere we see infinity leading to this, it is synonymous to 0. It is equal to 0. Equal to 8 minus 0 all over 7 plus 0. 0 is 0. 0 is nothing, actually. Minus 0 is still 0. 0 is nothing. We just pick out the 8 and 7. 7 over 8 over 7 equals to 1.1428. So that is it about limits lead to infinity. Remember, when you see question like this, go straight to the denominator, divide through by the highest power of x at the denominator. That will give you the right answer, and that is the appropriate approach to this kind of question. So let's go to question 3. Evaluate limit as x approaches infinity. So I told you before, infinity under limit, we pay reference mainly on the denominator. So all I'm trying to say is that when you see questions like this, you look for the highest power of x at the denominator, then use that power of x to divide the numerator and the denominator as showcased on the board. Limit as x approaches infinity, where you use this 10x raised to the power 3 divided by x raised to the power 4, as I told you before, that which is the highest power of x at the denominator, then plus 7 raised to the power 2 divides x raised to the power 4 minus 12 divide x raised to the power 4. The reason why I use x raised to the power 4 because according to the rules and formula of limits, when dealing with infinity, we tend to divide it with the highest power of x at the denominator. So that should be noted as well, which is to be very helpful and as we continue. Now, x leading to infinity, as let's start with this one, x tend to cancel it out each other. Now, this is synonymous to x times x times x all over x times x times x times x. This one, this x cancel this x cancel this x cancel this, remaining 1. That's how we got to this point. So the 3, 4, remove 3 from 4, which will give us 1. So 10 divide x. Why we do the same for the second? Why just remove 2 from 4, give us 2 s raised to the power 2 minus this one 12 raised to the power 4 raised to the power x raised to the power 4. The reason why we don't into the cancel, because if you look closely, the 12 does not carry any x or x with any power. That is why we tend to repeat the same in this place. Now going to the denominator, 15x raised to the power 4 divides by x raised to the power 4 plus 15x raised to the power 2 divides x raised to the power 4. So removing, subtracting 2 from 4 to give us x raised to the power 2 plus 4 divided x raised to the power 4. So you should be careful when dealing with this kind of maths, because it is very easy to make mistake. That's why you should be observant and very careful when solving this for to avoid error. Now to proceed with this, so thank this is this is how it should be. Now remember that it is limits when x approaches infinity. Infinity is things we can't count. When we infinite, something is infinite, something we can't really count, something we can't number, something that is unnumberable. Now that is why it is termed infinity. Now let's take this one now. We try to substitute wherever you see x, we substitute it with the symbol of infinity. Now this x, you have x here, remember that one, plus 7, we have x here as well, plus we have x here as well. There's no x here, we have x here as well, you have x as well. So wherever you see x now, just replace it by the symbol of infinity. This is how this solving goes. Now 10, I told you before, there's x here, just replace it with this infinity symbol, where we have 7 raised to 7 divided x raised by 2. Just say you replace it with the infinity symbol. Wherever you see have x here, you just replace it with infinity symbol. And now when we are at this level, it is case closed already because the answer is already right before our eyes. Now, wherever this symbol is, that place tends to turn 0. Everything totally turns 0. Now, okay, now since it's like that now, 10 raised to the power infinity is 0, 7 raised to the power divided infinity is 0, minus 12 divided infinity is 0. The only exception is the 15 because it is devoid of the symbol infinity. So now, regards to that, 0 plus 0 minus 0 is everything 0. While the denominator, we only have 15 as the real number. Now 0 divided 15 is 0. That is for 3. So remember that infinity, we tend to divide them, we attempt to solve this with the highest number at the denominator.
Right, 0.
No, now 0 divided 15 is 0. Okay, question number 4. Limit when x approaches infinity. Thank you. When you see question like this, just take a deep breath. I know most of you we already know what to do. Just, first of all, we have the trig and a number here, 5x. First and foremost, before you dig in or try solving, know that you first pay reference to the 5x. This is another approach. We choose the most complex formula pattern. I choose this one because this is very easy to understand and easy to assimilate. So now, we first of all differentiate the 5x. When you differentiate 5x, it will give you 5. How come about that? Okay, let me show you now. 5x. Remember, this one is raised to the power of 1, right? So now, differentiating this x, the power, which is 1, tends to come in front of this, which is 1 times 5, x. Now, remove 1 from the power. 1 initially, remove 1 from the power. So, 1 times 5, x, 1 minus 1 is 0. So, anything raised to the power of 0 is 1. Remember that one. Everything raised to the power of 0 is 1. This now leads to 1 times 5 raised to the power 1. So 5 times 1 is 5. 1 times 5 is 5. So that is how we got to this place. After differentiating the 5x, then we go straight to the trig, which is the sign. Differentiation derivative of sign is cos, while the derivative of cos is minus sign. Notice that one. Now, this is sine now. The derivative of sine or the differentiation of sine is cos. Then I told you after differentiating the 5x, which will give us 5, differentiate the trig as well. When differentiating the trig, it will give us cos. Then repeat what you differentiated. That is all about it. Nothing more, nothing less. That is what you should do. Then after the numerator, we go straight to the denominator. Then repeating the same approach we took earlier. Differentiating the 2x, it will give you 2. Remember how I solved it? Then which is the 2 that we have here. Then differentiate the 3, which is the sine. Differentiation of sine will give us cos. That is the cos here. Then rewrite what you differentiated before, which is the 2x. That's how we got to this place. Now, Remember, x approaches 0 when x approaches 0. So wherever we see x now, we tend to replace it with 0. Notice that one. So now, that is 5 cos 5x, instead of writing x, replace it with 0. Please don't forget. Replace it with 0. Now, that is for the numerator. Why the denominator repeats the same thing, leading to this place. 5 cos 0. Remember, so your secondary school, I don't know, but cos 0, remember it to give us 1. Y sin 0 will give us 0. So cos 0 will give us 1, which is 5 cos 0, 1, bracket open and close 1, all over cos, which is just 2, cos 0 will give us 1. So 5 times 1, 5, 2 times 1, 2. So 5 divided 2 will give us 2.5. So if you have any challenge pertaining to limits, you can drop it at the comment section. We will lay it into consideration. We promise to solve it and maybe explain more, because this is mainly the part student tends to fail, and we promise to do justice to it. So remember the formula of the limit. I told you, when solving limit, first of all, go straight to the denominator. It is when after looking at the denominator, you know the method to use. If the question is linear, remember, any linear question on the limit, you use direct substitution. If the question is just straight without any division sign or all over something, you don't use any other method except there is division sign. Maybe you have I don't know, you have maybe square root x squared plus 2x plus minus. This is a linear question, so you tend to use direct substitution. You don't need the L'Hopital rule or factorization. You just impute the value directly. So any question, feel free to ask. Please like and subscribe so that you get notified when we post new videos. Thanks and God bless.